Hi everyone. Today I want to talk about graphing sine and cosine functions. Whew. Let's remember our sine function. A couple of the important things about the sine function to remember for this video is sine always starts at the center, meaning it starts at the origin. Now you can see that if it starts here, right, its period is still 2 pi, right? Its period before it starts to repeat itself. So it starts at the center and goes up first. That's super important to remember about sine functions. Here we have our formula to remember our ABCDs and the breakdown of what each part means. That's going to be super important for later. Cosine function, in difference to the sine function, it starts at the top, meaning it starts at its max value. So when we have our value of cosine at 1 or 0, 1 on the y-axis, it starts high and then goes low. So when we talk about the center or the midline or what we call the vertical shift, that's also important to remember about a rule of thumb where these functions begin when we start to graph them. So again, we have our formula, we have our equation, and important things to remember. Let's jump right into it. So I made the key a little bit smaller here because we're going to be able to reference this a little bit easier throughout the process. Now, here are the rules for graphing. There's a lot, obviously. But it is sequential and it is step by step, and it also works every single time. So if we can graph really difficult functions or really difficult transformative functions, we should be good to go with any graph. So let's just go really difficult at first, and then we'll take it from there. Wow, that's really difficult. Here we go. We want to graph the function 2 sine times the quantity x minus pi over 4 minus 2. Just a simple note here, x could be theta. It's the same exact thing. It just is the unknown or the angle measurement that we're trying to figure out, right? So a couple of things we want to do first. Number 1, don't worry, it's going to be okay. And number 2, as long as you do step by step, you're going to be fine. Number 1, or the first rule, we can set bx plus c equal to 0. Well, what is bx plus c? Well, bx plus c is this parentheses part. Now, we don't actually have to do bx plus c. If you know what the phase shift is, then we're good to go. See, we have to find the phase shift first, and that's what rule 1 is doing. So this is our phase shift. And the reason we need this first is because phase shifts are our right or left horizontal shift. Well, we can't always start at 0. We can't always start the period at its 0 point, because if it was shifted left or right, that's going to be our new starting point. So we have to identify that first and graph that first. So let's do that. Here, our phase shift is right pi over 4 units. And we know it's right because it's a dirty liar, no good stinking liar, right? Because it has a negative in front. Normally that would mean minus or left. No, it's right. So, as in not correct, it's actually right, the direction. So pi over 4 units to the right is where this function is going to begin. So that's going to be one of our very key points that we have to write. So let's look at our graph. 0 to pi, and pi over 4 is, well, if this is pi over 2 right here, which makes sense obviously because that's half of pi, our pi over 4 value is going to be right here. Now, I can probably guarantee you, I can't exactly guarantee you, but I can probably guarantee you that graphs that you have when you're actually doing these for real, they'll be a little bit more sequential or a little bit more ordered in terms of what increments are there. If not, we can still identify where the pi over 4 is. This is where the phase shift is, meaning it shifted right pi over 4 units. This is the beginning of our graph. Now, number 2, we want to take the beginning or the phase shift and we want to add the period to it. Because what we do when we graph these things is we only graph one full period. Graphing the entire sequence of the problem is, number 1, not efficient, and number 2, not easy, right? So we want to graph one period at a time because we know after one full period, the function repeats itself. So if we know the basis of it, we can certainly just do the repeating process over and over again. So let's do that. We know the period is 2 pi over b, and b is the coefficient of x or theta. Well, the coefficient of x or theta is 1. So our period is 2 pi here. So we're going to add 2 pi to pi over 4. Let's do that here. And we can do that long ways, or if you know that in your head, then that's totally fine. I don't. So we're going to have to do this long ways. Pi over 4 plus 2 pi is 2 pi over 1. And I need that because I need to get my common denominators. Multiply by 4 on top and bottom, and that's going to give me pi over 4 plus 8 pi over 4, which is 9 pi over 4. That is going to be the end of the period. So let's go ahead and plot this. 8 pi over 4 is just a really fancy way of us saying 2 pi, right? Because it simplifies to 2 pi. So 9 pi over 4 is one more quarter increment after 2 pi. So here, about is going to be 9 pi over 4. That is our second key point. Now, if you read ahead a little bit, we need 5 key points. And this part's actually pretty simple. This is the beginning of the period, and this is the end. Well, I need 5 key points, meaning 3 more in the middle, which is going to break this up into 4 independent but equal sections. Now, sidebar. Why do we need 5 key points, and why is it broken up into 4 key sections? Well, if we think about the unit circle is broken up into 4 key sections too, and they are 90-degree increments, equal 90-degree increments actually, because on the unit circle there are 5 key points. 0 degrees, 90 degrees, 180, 270, ow, and then back to 360. Those are our 5 key points on the unit circle. So we need 5 key points on here to represent the entire duration of the period of one full unit circle. Okay? 1 pi over 4 and 9 pi over 4 is 10 pi over 4 if I add them together and divide by 2, which is 5 pi over 4. So 5 pi over 4 is going to be kind of like our median value, right? Our middle value, right? So 1 pi over 4, 9 pi over 4. Well, if this is 4 pi over 4, meaning pi, 5 pi over 4 is going to be right in the middle. And I'm a little bit off because I'm obviously doing this by hand. So this is going to be our middle value, 5 pi over 4. Now, again, if that was the median, I need 2 more values. Think about like a box plot, right? And I need the median of this upper part and the median of that lower part. So the difference here is 4 pi over 4, so I need to add 2 pi over 4 to this value or subtract it. So 7 pi over 4 is what I'm looking for here, right? And that's just before, or the last quarter before another full pi goes through. So 7 pi over 4 is here. And then 3 pi over 4, because again, that's the difference between 1 and 5, is here. Now we have our 5 key points. Now we can really get going on finalizing or going through the process of doing this graph. So we just completed step 1 and step 2. Step 3, we're going to plot the midline. Now, this is where midline is useful to understand the word midline. So the vertical shift here is -2, or the midline is -2 here. Meaning, because our midline normally is 0, because right, our parent function doesn't have all this stuff on it, we're actually going to go 2 units down. Now this graph is by 2s, so we have to be careful. We are going to make a dashed line at the midline. So I'm just going to go from the whole duration here. This dashed line, I want you to think of a highway, or I want you to think of drawing the line straight. It's hard because the camera's in the way. No. Okay. I want you to think of like a road that has the dashed yellow line in the middle, or the dashed white line in the middle, right? And then we're going to be drawing its boundary lines that are solid, right? So we're going to have like a highway, okay? So that's the midline. Now, step 4 is we're going to use the amplitude to find the max and the min, meaning the top of the highway and the bottom of the highway. Well, the amplitude is 2 here. And again, 2 is absolute value. So we are going to go from the midline 2 units up, and then from the midline and 2 units down, right? Because that's going to be our boundary points where the function lives. So 2 units up from -2 is 0. I'm going to make a solid line there. I'm going to do the best I can. That's not bad. And then I'm going to go 2 units down from the midline. Now we have our nice little road. The function that we have here must live within the boundaries of this road. It cannot go above it and it cannot go below it, right? Because again, we have a maximum value at 0 and we have a minimum value at -4. And again, we know that because our A and our D values actually work really nicely together. So now we can actually start to plot some points. And this part's way simpler than it might seem. Sine starts at the center. It's a really good rule of thumb. This is a sine function at its parent. So sine starts in the center, meaning the midline. Now, we are not going to make a point at 0 because there was a phase shift. That's why our 5 key points are so key. I'm going to make a dot at the center of where we start, at pi over 4. And remember from the beginning of the video, sine goes up before it goes down. So if we start at the middle, I go up and make a dot at the max. Then I go to the middle again. I can't cross over the road completely. I have to make a pathway. Then on the next value, or my fourth point, I will go to the bottom. And then on my last point, I'm going to go back to the middle. Now, if I were to continue this process, I would go top, middle, bottom, middle, top, middle, bottom, right? Because this is a sequence and it's, you know, squiggly. So let's make our plot, and I'm never good at this. That was terrible. You get the point. This represents one full period. Oh, that's really bad. This represents one full period of this sine function, and we've graphed it. Now, again, we only want to graph one full period because it repeats. So from this point, it would repeat the same way. From this point, it would repeat the same way. You can very easily just continue with your quarter values here because they're all by 4s, and then just continue the process through, okay? So what did we do here? Number 1, we found the phase shift and graphed it first. That's important. Number 2, we added the period to the phase shift. And then we found our middle 3 points, which represented our 5 key points. We need those points to make these plots. Number 3, we plotted the midline or the vertical shift. And then number 4, we used the amplitude to find our max line and our min line to complete our road. And then 5, we finally plotted, which again, doesn't really take a lot of mathematical intuitiveness as long as you know sine starts in the middle, goes up, cosine starts at the top and goes down. And we'll do a cosine value right now. Okay, so here we have a cosine function, 2 cosine x plus 3 pi over 4 plus 1. Same exact process, the only difference is we have obviously some different numbers, and we have a cosine function. So let's go ahead right to it. Phase shift comes first. I could set this parentheses equal to 0, but because I don't have a coefficient here, I just know that this is a left 3 pi over 4 shift. So we start from the 0 always, the origin, right? Because that's where the 0 degree mark is on the unit circle, the beginning point. I'm shifting this graph over the entirety of it to the left 3 pi over 4 units. So again, we have a 4, which means that this increment of 0 to negative pi can be broken up into 4 sections, right? Or 3 little dash marks. So 3 pi over 4 negative is about right here, right? Because 4 pi over 4 would be simplified to pi. So again, I'm going to estimate it as best I can. This is negative 3 pi over 4. Now, that's the beginning of this graph. Next step is I'm going to add the period to this initial point to find its finalization point, or its last point. So the period is 2 pi divided by b. b is the coefficient of x. Well, b is 1. So our value for period is 2 pi. So let's add this. I have a negative 3 pi over 4 plus 2 pi. Make it over 1, get a common denominator. So again, we're going to have an 8 pi deal here. Negative 3 pi over 4 plus, that's a weird 4. It kind of looks like a y. Sorry. 8 pi over 4. And that's going to be 5 pi over 4. That is the end, or the 5th value in our sequence. So 5 pi over 4 is 1/4 increment more than 4 pi over 4. And 4 pi over 4 is just pi. So we're going to go right here. And we have a 5 pi over 4 value. This represents one full period of this function. So let's find our median and then the medians of those. So negative 3 pi over 4 and 5 pi over 4, there's a distance between them of 8 pi over 4, right? So 8 pi over 4, if we divide it by 2, is 4 pi over 4. So I'm going to subtract 4 pi over 4 from 5 pi over 4. So I'm looking for 1 pi over 4, which will be the middle. So 1 pi over 4 is 1/4 increment of pi after the 0. And again, I'm trying to see it, but the camera is super intrusive. This is 1 pi over 4. And it looks about the middle, right? So now we've got our third point. We want to find the middles or the medians of those two sections. So if this is 1 pi and 5 pi, we have a 3 pi over 4, which is the third quarter or third part of this increment. And then this one, again, it's a 4 pi difference. So I'm going to either add 2 pi to that or subtract it to that. It's just going to be a -1. So negative 1 pi over 4. And I'm going to put the 1s here so it looks a little bit better so we can subtract and add. Now we have our 5 key points. This represents one full period of this function. Great. Now let's get to the easy stuff. The easy stuff really is number 3, number 4. Well, let's plot the midline. Well, the midline is plus 1. So we start at 0 at the midline. I'm simply going up 1 unit. Now, at 1, I'm making a dashed line because that is our middle of our highway. Midline, get it? Middle. Now let's go to the amplitude, which again is very simple. Amplitude is 2, which means that is 2 full units above the midline and 2 full units below. So if this is 1, 1 plus 2 is 3. So 3 is going to be our maximum value, which is the boundary line of our highway at the top. And then if 1 is our midline, we're going to take 2 away or subtract 2, which is a -1. So it's going to overlap a little bit here on the numbers. I'm sorry. And again, they should be equidistant from the midline, right? You should have the same distance from here to here as you do from here to here. That's what the amplitude is, right? So now we got our nice little highway. So let's start driving. That's not funny. Plot the points. Remember, sine starts in the middle. Okay, well, again, I'm not starting at 0 because there was a phase shift left. I am putting my center dot right here because that's my first point on this value. Now, because this isn't sine, it's cosine. Thanks for telling me. Cosine starts at the top, right? So cosine starts at the max value, because again, we have cosine here. So cosine starts at the top and then goes downhill. So it starts at the max, which means my next increment must go to the center, because again, we don't cross over the highway. We have to take a pattern. And then it goes to the very bottom. Then it goes back up to the next possible line, which is the midline. And then it goes up to the top, which is our last value. Now again, for some sequence, I'm going to just do the hanging part here. This represents 1 full period of this function, 2 cosine x plus 3 pi over 4 plus 1. And again, I can continue this process because it just repeats itself. All I would need to do is make more quarter increments throughout the process. Let's finish up with one more problem. So we could set bx plus c equal to 0. Now the problem with that is this isn't a plus, it's a minus, right? So remember that minus signs mean to the right. So we can do the bx plus c equals 0, which is totally fine. Or we can just do what we know. We can do c divided by b. So let's do that. So c is negative pi, and b is 2. So this is going to be negative pi over 2. So negative pi over 2 is right pi over 2. This is the phase shift. Right? So the phase shift is going to be where we start our function, not at 0. So again, it's negative, so it's going to the right. So this is a right pi over 2 phase shift. So let's go ahead and find where that is. Pi over 2 is not bad because if this is pi, distance of increment of pi over 2 is right in the middle. Okay, that is the beginning of our 5 points. Let's add the period to this. Well, the period is going to be a little different because I have a coefficient of x. Remember that the period is 1 full cycle, but it's 2 pi divided by b. Well, b is 2. So 2 pi over b, or 2 pi over 2, is just pi. So the period is only pi units here. Okay, so let's add that, right? So pi over 2 plus pi over 1, get a common denominator. This is pi over 2 plus 2 pi over 2, which is 3 pi over 2. All right. Now, 3 pi over 2 represents the final portion, or the ending of our full period. Okay, well, if this is 1 pi over 2, 2 pi over 2, 3 pi over 2, meaning it's halfway between the regular pi and the OG 2 pi. Now, I want you to notice something. This is a full period. There's going to be 3 more dash lines here. This function is really compressed, and we know it's going to be compressed because in transformations world, the number or coefficient that's in front of x, when it is a whole number, that actually represents a horizontal compression or a horizontal shrink, meaning it's going to get really squeezed together here. So transformation rules exist throughout every lifeline of every function that we know. It's exactly the same process. It's just wrapped up in a different package for trig because it's a little bit different because we have radians. So there is going to be a really significant compression here in terms of our function. Let's find out the middle points. Well, this one's not too bad. If that's 1 pi over 2 and that's 3 pi over 2, the middle is pi. And you can kind of see that on this graph. So this is going to be our 2 pi over 2, or just pi middle point, sorry. Now, in the middle of these two things, we have to have a quarter increment, right? So if this is 1 pi over 2, I need values here and here. So pi over 2, this is 1 pi over 4. So we need middle points for both of these things, right? So if this is 2 pi over 2 and 3 pi over 2, that's 5 pi over 2 divided by 2. Now 5 pi over 2 divided by 2 is 5 pi over 4, because I'm multiplying by the 2. Now if that's 5 pi over 4, this should be 3 pi over 4. And we know that because we can just add these things together. So if I were to do the 2 pi over 2 plus the 3 pi over 2, I would get 5 pi over 2. But I need half of that because it's like I'm adding the two things together and dividing by 2. So dividing by 2 is the same as multiplying by 1/2. So I'm going to have here 5 pi over 2 times 1/2, which is 5 pi over 4. And then I would do the same process for 1 and 2, which is 3 pi over 2 divided by 2 is 3 pi over 4. And again, they're quarter increments. So if we have halves, the next smallest number down would be a quarter, right? Now you can see what I'm talking about maybe a little bit better. This is one full revolution or one full period of our function that we see here. So it's going to get a little funky. Hopefully I'll draw it better. Next, let's go to the midline. Well, the midline is -1. So I'm going to make my dashed line at -1. And I'm just going to go through the duration of it so you can see it a little better. That's a terrible line. 4, I'm going to use the amplitude to find the max and min lines. Well, the amplitude here is 3. So if this is a -1, -1 plus 3 is 0, 1, 2. So I'm going to go up to 2. Now, that seems like a really big midline. There's a lot of difference here, a lot of distance. And that makes sense, though, because if I compress a function, it's going to get shorter in the increments, but it's going to get bigger on the vertical. Now, that makes sense, too. Like, for example, if I was to compress myself, right, I would get way, way, way shorter, but I get way, way, way fatter, right? So that's kind of how the give and take process, the cause and effect of shrinking or stretching things. If my amplitude is 3, I'm going to go 3 units down from the -1 line, which is -4. All right, now we have a really big road here, but our function is going to be really, really, really quickly kind of spiraled. Now we can start plotting. Sine starts in the center. Thanks. Sine starts in the center. So if I got pi over 2, I'm making my center point here, and sine goes up first. So center point to the next increment, back down to the center point, back down, way down to the minimum, and then back up. So let's see what this looks like. Okay, and that is one full period of our sine function. Because from here to here, I started here and I ended here, right? I started going up here and then I ended by stopping from going from below. It repeats here and it repeats here. We can continue the process by quarter increments and we can go from there. Let's finish up. Things to remember about this video. Number 1, you've got to remember the rules of our ABCDs. If you don't remember those, it's going to be really hard to graph these things. So I think the practice on ABCD is important first, because graphing it really is just, can you plot those points? Because those 5 key points are obviously critical, and then we can go from there. Number 2, not every function has the transformative components that we've done today. It's actually way easier if they don't have all these pieces. And the reason for that is because we basically had one of every single transformation except x-axis reflections. That'll be a different video. But when I have something that's simple, like just an amplitude, for example, all I need to do is plot that, meaning I can skip steps that I don't need. Those steps are all inclusive of graphing the worst transformation graphs you can find. But when it's easier, when there's less stuff, just skip what you don't need. Okay? And number 3, just like the last video, understanding ABCD is going to make graphing way easier, and it opens up the door for just a way better, more comfortable process when we get to the higher level trig functions. See you next time.